Good, and welcome to another deep dive into the cutting edge of artificial intelligence. Today, we're unpacking one of the most transformative architectures in modern AI, the transformer. If you've ever wondered how models like GPT or BERT achieve such remarkable language understanding, you're in the right place. Let's get technical. First, let's step back. For years, recurrent neural networks RNNs, and their variants like LSTMs dominated sequence modeling. But they had a critical flaw. They processed data sequentially, which limited scalability and made parallelization nearly impossible. Enter the transformer, introduced in 2017 by Vaswani et al. Inattention is all you need. This paper didn't just refine the field, it redefined it. At its core, the transformer replaces recurrence with self-attention mechanisms. Think of it as a way for the model to weigh the significance of each word in a sentence relative to others. For example, in "the cat sat on the mat," the model learns that cat and mat are more semantically linked than the and on. But how does this actually work? Let's break it down. The transformer relies on three key components: the encoder, the decoder, and the attention mechanism. The encoder processes input data, converting it into a series of hidden states. The decoder then generates output, using the encoder's states to inform its predictions. But the real magic lies in attention. Self-attention operates by computing three vectors for each word: queries, keys, and values. These vectors determine how each word interacts with others. The dot product of a query and key gives a similarity score, which is scaled and passed through a softmax function to produce attention weights. These weights are then applied to the values, creating a weighted sum that represents the word's context. But wait, there's more. The transformer introduces multi-head attention, where the model independently learns different representation subspaces. Imagine multiple gazes on the same data, each capturing distinct relationships. For instance, one head might focus on syntax, while another deciphers semantics. These are then concatenated and linearly transformed, allowing the model to capture complex patterns. Now let's talk about positional encoding. Since transformers don't process data sequentially, they need a way to understand word order. Positional encodings are added to input embeddings, using sine and cosine functions of different frequencies. This allows the model to infer distances between words, effectively embedding positional information into the data. Another critical innovation is the feed-forward neural network, FFN, that follows each attention layer. While the attention mechanism captures global dependencies, the FFN handles local transformations. Each position in the sequence is processed independently here, enabling parallel computation. But the transformer isn't just about language. Its architecture has revolutionized tasks like machine translation, text summarization, and even image processing. Variants like vision transformers, ViT, have shown that the same principles apply to non-sequential data, blurring the lines between modalities. So why does this matter? The transformer's ability to scale efficiently has paved the way for massive models like GPT-3, which boasts 175 billion parameters. These models don't just mimic human language, they generalize across tasks, achieving state-of-the-art results with minimal fine-tuning. Of course, challenges remain. Training such models requires immense computational resources, and their black box nature raises questions about interpretability. But the field is evolving rapidly. Recent advances like sparse attention, efficient transformers, and hybrid architectures are addressing these issues, pushing the boundaries of what's possible. In closing, the transformer isn't just a model, it's a paradigm shift. By prioritizing attention over recurrence, it's unlocked new frontiers in AI, enabling systems that understand, generate, and interact with human language in ways we once thought impossible. As research continues, one thing is clear: the transformer is far from the end of the road. It's just the beginning. Thanks for watching. If you enjoyed this deep dive, hit subscribe for more explorations into the science behind AI. Until next time, keep questioning, keep learning, and stay curious.